Welcome to this session. In this session, we will try to understand what is classful addressing. Okay. So this concept you might hear from somewhere and you might ask why I have not covered. That's why I thought of covering this concept. So let us understand this. So we have around 2 raised to power 32 is equals to 4 billion, 4 plus billion addresses, right? So when initially these addresses we were having, how to categorize the addresses. So that categorization was done by classful addressing. That was a very initial, okay, initial categorization. Okay, so classful addressing is a old. So this old is important. Old system where IP addresses were divided into the fixed classes A, B, C, D, E, and each class has a predefined network size. So the IP addresses were divided into A, B, C, D, E. Okay, and each were having some size. Okay, and there was a purpose. If you are coming from some organization, then you should go for C. If you are coming from some huge network, huge company network, you should use A. So that kind of thing was there. So we will understand it. Okay, so how these addresses are classified into classes. So that is path that they have did based on the first octet. So we have seen, right? So we have a similar for this is 8 bit, correct. So similarly we have another 8 bit here, correct. So it is over here. So fine. So similarly we have another, right? So this is the first 8 bit. So this classification is based on this first 8 bit. Okay. So when we are considering A, right? So in A, the first bit is 0 and first octet range will go from 1 to 126 and it is used for very large network. And for B, the first bit were 10. First octet range will go from 128 to 191. It's a medium network. For C, first 3 bits are fixed. It will go from 192 to 223, small network. For D, it is first 4 bits are fixed and it will go from 224 to 239 and it's a multicast. The purpose is multicast. Okay. Then E, first 4 bits are fixed. Range is this one, experimental. Now only A, B, C are used for normal host. Okay, rest C, D and E cannot be used as host. Okay, now when I say multicast and experimental, I am sure now at this stage you would have understood what is multicast and experimental because we have covered it. Okay, now let us try to understand somewhat deeper, right? So this is another representation. Okay, so how it is arrived? So anybody will ask, right, how this is arrived? So let us understand first. If we understand first, then all others you can understand easily. Now class A we will take. Example of class A. Class A. So class A, what is the rule? Rule is first bit is fixed, right? First octet. So first bit is fixed, rest all can vary. Correct. So first bit is fixed. So the very first address will be what? It will be 0, 0. This X means those can vary from 0, 1. So initially all are 0. Now this what will be the decimal representation? It's a 0. The first octet. This is about first octet. Okay. So this is 0. So the value starts from 0. Now all are 1. Correct. This is the last. This is the first one. Correct. This is the last because we are considering everything as 111, right? So what will be the value of it? So what will be the value of this? How to compute it? We have seen it, right? So if you want to convert it to decimal, then you just put the number of bit position into 2 raised to the power. So 2 raised to power 0, 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3 plus 2 raised to power 4 plus 2 raised to power 5, 2 raised to power 6. Correct. And this is the seventh position, right? Which we are not considering. So 2 raised to power 0 is 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64. So this sum will come as 127. Correct. So the range for class A will go from 0 to 127. This is the actual range. Okay. Now obviously you will ask me question. Okay. You are saying at one time 0 to 126. 0 to 127. Sorry. But here you are showing it as 1 to 126. Why that is? Because we have seen that 0.0.0.0. This address we cannot use, right? We cannot use this address. This is for any one address, right? We have seen this. This is a reserved address. So we cannot use it. Now 127.0.0.1 and all this range, right? 127 range we cannot use. Again, why? That is for your dev purpose. Correct. And it can be only taken up by your system. Means if some developer wants to develop some application, he want to test it locally, then this is the IP which he can use to test it. This IP cannot be used and routed over internet, right? So this also cannot be used. So that's why we are saying that the range will go from 1 to 126. So similar way, whatever we calculated here, right? So similar way you can calculate for other classes B, C, D, E, F, not F, only E. Okay, you can calculate. Now I have prepared one extra Excel to give you more beautiful representation of it. Okay. So you can see class A. Class A used for huge network. The binary rule is given as 0, XXX. So XXX means those can vary from 0, 1. And this is the binary rule for first octet. Okay. It's a binary rule for first octet. The range will go from 1 to 126 to 55. And the structure is network host, host, host. Okay. So the first 8 bit are fixed here. Okay. Default subnet mask for this class A will come like this. And how many networks are possible here? We have seen, right? 126. It can go from 1 to 126 and that is the network bit, right? So we have total 126 network possible. How many hosts per network possible is 16 777 So you can see that how big number is there. So that's why it's used by huge network. So it can be used by ISPs and government, and there is an example here. So this is one of the IP which can fall into this range. Then for class B, the first 2 bits are fixed. Rest can vary. The range will go from here. Okay. And the structure of this IP is network host. So this is 16, the first 16 binaries, right? Those will define your network. Okay. So how many networks possible and how many hosts per networks are given, and then it is used for university and enterprises because it can only host around 65,000 devices in one network. Okay. Then comes class C, that is a small network. Its binary rule is like this. Range will go this way and all first 3 three numbers in the decimal representation, right? Those are for network, rest are for host, and default subnet mask is this one. And networks are possible are around 2 million networks can be there. And how many hosts per network is 254 hosts per network. And this is the example. Okay. Now class D is for multicast, right? So this is the range for multicast and used for one-to-many communication. Now one-to-many communication we have seen, right? In which other cases like video streaming, game streaming, some stock market data streaming, all these purposes are used for multicast. So those can use this IP. Now class E for experimental purpose. Those are reserved and not used for public internet. So the range is something like this. Okay. So this is one of the representation which will give you all the idea. One thing which I want to tell you is this is the old system of classifying addresses. Okay. Nowadays, none of the router uses this. Okay. Now we will use CIDR. Now why we use CIDR? Because there is a big problems with classful. There are some problems. Some problems are massive wastage of IP. Waste of IP. Because we have seen, right, in class B, if you take a class B network, you have 65,000 devices. That many devices we cannot have, right? So if we take a class B address and we have only 30,000 devices, rest other IPs are going waste, right? So for example, company needs only 2,000 IPs. The smallest fit here will be class B, right? Smallest fit will be class B. But class B, if you take, you will get 65k devices almost. So it is a waste of around 63k devices, correct? This is why IPv4 exhaustion happened in the past. And to avoid this, we came to CIDR range. Now all router uses CIDR. Okay. That's why this classful addressing is gone. None of the router uses it. So CIDR, how CIDR helps? CIDR simply by defining this way, right? 24, 32, 23. You can control the number of hosts very easily, and this way it will not waste. If you want around 2 raised to 8 means you want 255 devices, take CIDR of 24, right? If you want 127 devices, for example, take CIDR of 23, right? So this way you can control this IP. That's why CIDR is helpful. So that's all in this session. If you understand this well and if you like this video, do share and subscribe and do tell your friends about my channel. Thank you.